Alrighty, so we are recording and we are going to continue with matrices on the whiteboard function. No, I don't want to start whiteboard immediately. I want to remind you guys of what we did last time. All right, that one, share, and I want to share the picture. All right. So remember, this is what we did with matrices last time. I said to you, imagine you had this system of equations and you had to solve it and you could get these answers, and that's perfectly fine. But what happens if you have a more complicated system and you can have multiple variables, multiple equations? Then what you're going to do? Well, that's quite a problem. So I said that we are actually able to write a matrix of coefficients out of this. But a more important question is, why? Why am I able to do this? Why am I able to just take the numbers in the front, completely ignore the x and the y, and magically math just happens, and then we get an answer? Now, yes, maths is quite magical. It's an amazing subject. But what makes it even more amazing is answering the why questions. All right. So to answer that why question, we need, good question, Rebecca. I will sort that towards the end of the session, but thank you for reminding me. So we need to know a little bit more about matrices. All right. So let us have a look. Now we are going to share the whiteboard. So matrices, just like a lot of things in maths, have operations that can be done with them. So just like normal maths, we have numbers. So you can have 2 plus 3 is 5. You can have 2 minus 3 minus 1. Just want to check. Hopefully I'm not straining anyone's mental faculties at the moment. If you have 2 times 3, you get 6, because now we're getting complicated. And 2 divided by 3 gives me 2/3. Whoa! Fractions. All right. So that's not the complex part of the lesson. These are called operations. So all of these signs that you have over here are known as operations. And we can do operations on matrices as well. So remember, in a matrix, you have rows and you have columns. And in a matrix, we can have any number of rows and any number of columns that we want. So if I want to work on, for example, let's do a 2 rows. So 2 rows and 3 column matrix. So I'm going to have an element here, an element there, an element there, an element here, an element here, and an element here. So 2 rows, 3 columns. Obviously, there's going to be 6 elements because for each row, there's 3 columns. 3 by 2 is 6 elements. Now, when we specify this type of matrix, you always specify the rows first. So this is known as a 2 by 3 matrix. So in English, 2 by 3. You don't say a 2 times 3, even though you times by a number. It is a 2 by 3, or a 3 by 2, or a 3 by 3, or a 6 by 5, or a whatever you use by. Now, let's have a look at addition. So addition with matrices is very similar to subtraction, but the addition you need the same dimensions. Whoa, what the word dimensions mean? Well, these are the dimensions. It is the size of the matrix. Just like when you deal with area or perimeter or something like that, you deal with dimensions, the length and the breadth. Here we're dealing with the rows and the columns. So I'll give you an example. We could have a matrix that goes 3, 5, 1, 2, 4, 9, plus 8, 11, minus 4, 2, 8, 0. These two matrices can add together because this is a 2 by 3 and this is a 2 by 3. If we add them together, surprise, surprise, we're going to end up with a 2 by 3 matrix. And how do we add matrices? We add them element by element. So 3 plus 8. 5 plus 11. 1 plus negative 4. 2 plus 2. 4 plus 8. And 9 plus 0. So it's literally this plus this, this plus this, etc., etc., this plus this. So you literally added element by element. And then you don't write that as your final answer. You would have to actually write what the actual answer is going to be. So 3 and 8 is 11. 5 and 11 gives me 16. 1 plus negative 4. Hopefully no one is tripped up by this. You can use a calculator if need be. A plus and a minus makes a minus. So 1 minus 4 gives me minus 3. 2 plus 2 is 4. 4 plus 8 is 12. And 9 plus 0, don't strain yourself here, is 9. So this is my 2 by 3 matrix. 2 rows, 3 columns. Great. So addition, we can do. Now, what happens if we deal with subtraction? So let's actually use the exact same example. And I am going to get rid of that. I'm going to get rid of that. I'm going to get my pen back. All right. Subtraction. If you're subtracting matrices, again, we need the same dimensions. As I said, addition, subtraction, very similar. The exact same example with a minus. What happens? Pretty much exactly the same thing. Element by element. 3 minus 8. 5 minus 11. 1 minus minus 4. 2 minus 2. 4 minus 8. And 9 minus 0. All right. And then we can write this out as a final answer. So 3 minus 8 is minus 5. 5 minus 11 is minus 6. And 1 minus minus 4, the double minus makes a plus. 1 plus 4 gives me 5. You can check all of this sort of stuff in your directed numbers section. 2 minus 2 is 0. 4 minus 8 is minus 4. And 9 minus 0 is 9. And again, we end up with a 2 by 3 matrix. All right. So you're looking and saying, that's great. I don't see how the hell this is going to help me with solving a system of equations. But let's have a look. All right, so we've done addition. We've done subtraction. Anyone at the moment unclear? They have some questions. They don't know what I'm talking about. All right. Let us look at multiplication. Multiplication, now we kind of have a little bit more. I'm supremely glad that we have people that can do 9 minus 0 sufficiently well. Some people are choosing to not understand, and unfortunately that is your choice then. With multiplication, multiplication is slightly different. So I am going to use the same example again, and unfortunately I did clear it, but I'm going to quickly try and pull it up again. All righty. So we had a 3, a 5, a 1, a 2, a 4, a 9, and then we had an 8, an 11, a minus 4, a 2, an 8, and a 0. All right. If we try and multiply these matrices together, we are going to end up with a problem. And the reason for that is because our matrices need a different characteristic. These are currently 2 by 3 and 2 by 3. For matrix multiplication to work, these two inner dimensions need to be equal. And as you can clearly see at the moment, they are not equal. So what I'm going to do is I'm going to rearrange this slightly so that it will work. Please take note, if the multiplication does not work in a test, being you're given some question or you worked out something, you are not able to just rotate the matrix or something like that. That changes the whole thing you are working with. Because I'm simply coming up with examples, I'm going to create a brand new example that has no relevance whatsoever to the previous questions at all, and it is just simply random numbers that I am picking. All right, this is now a 2 by 3. This is how many rows? 1, 2, 3. How many columns? 1, 2. Are these inner dimensions equal? Yes, they are. Because they are equal, we can now do our multiplication. And when you see the process of multiplication, you'll understand why these two need to be equal. Even more interestingly, is that not only do these two numbers have to be equal and tell you something, these two numbers will actually give you the dimensions of the resulting matrix. All right. So after you multiply these two matrices together, your answer is going to be a 2 by 2. Now, this might be a little hard to comprehend because you're like, you've got a 2 by 3, you've got a 3 by 2, and now your answer is a 2 by 2, which is neither of those two sizes. Let's just, if you are a little unsure, you're like, hold on, this is a bit much for me. Don't worry. Stuff will become a lot clearer soon. All right. So we are clearing this so that we have space to do our multiplication. All right, let's do our multiplication. When we multiply, we need to make sure that we multiply element by element, but more importantly, it's row by column. You're like, yes, I know, you said row by column, that's the dimensions. No. We are multiplying a row from this matrix by a column of this matrix. So as I said, this is going to end up being a 2 by 2 matrix. So there's going to be something there, something there, something there, and something there. So this element over here, remember I said you can name it as a 1-1 or a 1-2 or a 2-1 or something like that. So here, this element is 1-1 because it's row 1, column 1. So we're going to multiply row 1 from here with column 1 from here, element by element. So we're going to take the 3 times the 8, the 5 times the 11, and the 1 times the -4. So essentially the way that you look at it is left hand. So you can put both your fists up normally. Your left arm goes across, your right arm goes down. So as you multiply, you do that. So you go across the row on the left, down the column on the right. Once we come to this one, we need to say, all right, this is in the first row of my answer and the second column of my answer. Therefore, I'm going to take the first row and multiply by the second column. So 3 times 2, 5 times 8, and 1 times 0. So 3 by 2, 5 by 8, 1 by 0. Similarly on this one is in the second row and the first column. So there's my second row, there's my first column. So again, across with down. 2 by 8, 4 by 11, and 9 by -4. And the last one is second row, second column, therefore second row, second column. 2 by 2, 4 by 8, and 9 by 0. And here we see how we get our 2 by 2 in the end, because there's only 2 rows we can multiply and 2 columns we can multiply. So let us work this out. So 3 by 8 is 24. 24 and 55 is 75. 75 minus 4 is 71. That is 6. That is 40 is 46. And 0 is 46. That is 16. And 44 is 60. 60 minus 36 is 24. And that's 4, and 32 is 36, and nothing makes 36. Possible I made some calculation error, but it should be about that. So hence we can see this is our answer of a 2 by 2. Yes, so Tyler, absolutely right. You're most definitely going to be able to use an exam, a calculator in the exam for this. Luckily, if you use the new Casio calculators, they actually have built-in matrix functions that can do this for you. All right. So this multiplying is very important for this solving of our systems, because that is how we are going to see how we actually use this multiplication in the system. All right. Save. So I'm going to clear this, and I'm going to do one more thing with you. right? And you remember that our system at the very beginning was x plus y equals 3, x minus y equals 1. And I said to you, remember, you've got coefficients here, coefficients here. Now, having a look back at the multiplication example that we just did, you had addition items as elements. So maybe, just maybe, this is the result of matrix multiplication. So I said to you, we could take just the coefficients. 1 plus 1, 1 minus 1. And the reason for that is because there is a vector over here, xy, that we're going to be multiplying on. And of course, I couldn't show you this before because you didn't know how to multiply. But now we do. So let's quickly check this multiplication. Dimensions here, 2 by 2. Dimensions here, don't get confused on which way around this goes. Always rows, then columns. 2 rows, 1 column, 2 by 1. Great. The middle are equal, therefore that is going to be the resultant. So let us now multiply. So remember, rows across on the left, columns down on the right. So rows across, columns down. So this is going to be 1 times x plus 1 times y. And then over here, it's going to be 1 times x plus minus 1 times y. And if we simplify that out, we get x plus y and x minus y, which is exactly what we have here. So this can actually be decomposed into a variables vector, or matrix, being a single matrix is a vector, and then your coefficient matrix. You're like, that's quite cool. Still don't see how it's going to help me. You've essentially just made it more complex for me. Before, I was just dealing with one matrix. Now, I'm dealing with 2 matrices, or a matrix and a vector. So it's not even all matrices, but it is matrices because this is actually classified as a matrix. Leaking out the side, out the ears, out the nose. All right. So this is quite amazing because this is exactly the same form as just simultaneous equations because maths is consistent. So in our next lesson, we're going to work out how do I solve this using matrices, which is quite amazing. And we're going to need division to deal with that.